the optimizing function is the next thing we're going to be talking about. We're building on our knowledge of polygon of constraints, except now we're going to give you an equation to find out what a maximum or a minimum of a situation would be. So in some situations involving a set of constraints, the target objective involves searching for the most advantageous solution. This solution may correspond to the highest value called the maximum or the lowest value called the minimum. This optimal value is obtained using the rule of a function known as the optimizing function. And it's not as scary as it sounds. So in real life, most people, when they build something or when they sell something, they want to make a profit. They want to have the most advantageous solution. Or if you are renovating a house, you get a bunch of quotes from different companies because you want the lowest value possible. You want the minimum to pay. So here's another example. A company that makes windows in 2 different formats is looking to maximize its profits. So they want to make the most money possible. Each week, it must make at least 200 windows, and the number of windows in format A must not be more than double the number of windows in format B. Each window in format A generates a profit of $85, and each window in format B generates a profit of $150. What is the goal of the company? Well, the goal of the company is to maximize profits. We want to maximize our profits. We want to make the most money possible. So we're going to calculate the rule for optimizing the function that will allow you to calculate its weekly profit. Now the thing here is, you do not, when you're dealing with the optimizing function, you do not need to deal with any of the inequalities. Those are your constraints. Okay? The maximizing or the optimizing function is usually what would be an equation. Okay, the sentence in your problem that symbolizes an equation. There's no inequality with it. So we're going to calculate the rule. So if X is number of windows for format A, right, we have to identify our variables and let Y equal the number of windows in format B, then the rule for the optimizing function is as follows. Usually in optimizing function, we don't use Y is equal to, we use P for profit, or we use Z for optimizing. Okay, both mean the same thing. So if we look here, I'm going to actually give it to you guys here. Each window in format A generates a profit of $85, and each format B, $150. So it's profit. We want max profit. So how am I going to calculate max profit? P is equal to $85 per format A window plus $150 for format Y window. That is how I'm going to calculate the optimal price, the maximum price. So just remember that when we're dealing with maximum or minimum amount of profits or maximum or minimum of anything, it is an equation in your question, not an inequality. And you always want to identify your variables. So let's talk about advantageous solutions. An optimizing function whose rule is written. So this is the form, right? It's in general form, okay? We also can use P for profit. So P is equal to AX plus BY plus C, okay? Allows you to compare ordered pairs. So it allows you to compare your X and your Y variables. It allows you to compare format A windows and format B windows. It allows you to compare apples and oranges to determine which among those ordered pairs constitutes the most advantageous solution given the goal. So the rule for an optimizing function can also be written in the following form here, but you don't need to worry about this. Keep it as Z is equal to AX plus BY plus C. Keep it simple, where X and Y are independent variables, functions of F, so you don't need to worry about that. We won't overcomplicate things. So here's another example. Below is a polygon of constraints and the coordinates of various points. Okay, so as you can see, we have a polygon here that's bounded, and all of the points on the inside, and now you can see all the lines are included in my solution set. As you can also see, we have a couple of points located on the inside of the polygon of constraint as well as on the edge. And we also have the rule for the optimizing function. Z is equal to 4x plus 2y. So, and I'm actually going to put this here because you can't really see it well, but there's the point, and Z is equal to 4x plus 2y. So, Among these points, we can note the following. Okay, so I want you guys just to pay attention here. Point F, which is up here, 3, 5, does not belong to the polygon constraints, and therefore you don't consider it as a potential optimal solution. If the target objective is to maximize the function, which coordinates represent the most advantageous solution? Well, what you do basically is you take every point that you can find that's included and you put them in this column here, as you can see. And then afterwards, what you do is you take your optimizing function and you plug in the x and the y values into your equation to get the answer. So if we want to maximize the function, we would probably want to use point E. Because point E, if I look at my optimizing function, 4 times 4, because that's the x value, plus 2 times 3, which is your y, you get an answer of 22, which gives you the most. So point E, which is right here, would be the maximum. It would give you the greatest dollar amount. Okay? Next one is, if the target objective is to minimize the function, so the least amount, which point would represent the most advantageous solution? Well, the most advantageous solution would probably be point A. So all you're doing basically in this chapter is understanding what the optimizing function looks like. So it looks like this, so to speak, and how to take points on your polygon constraints and put them into that equation to find out what the optimal solution would be. And remember that those points have to be included in your polygon of constraints. So now we're going to I want this one. Okay, so a company must build airplanes as quickly as possible. A Type A airplane costs $200 million to build, and a Type B airplane costs $125 million to build. The company has at most $5 billion to build the airplanes, and there must be at least 5 more Type airplanes than double the number of Type B airplanes. The company can't build more than 30 airplanes. It takes 3 weeks to build a Type A airplane and 5 weeks for a Type B airplane to get built. So we are going to identify a system of inequalities that represents each of the constraints. So first thing we need to do is we need to identify our variables. So let x equal the number of Type A airplanes, and let y equal the number of Type B airplanes. So we first of all have to identify the fact that we have non-negatives, because you can't have a negative amount of airplanes. We also have, there would be 200 million, we'll leave the millions out, we'll just keep it 200 million Type A's, plus 125 million Type B's would give us 500 or 5 million. Just so you guys remember, there's 1,000 million in a billion. Okay, that's why I'm using 5,000. Okay, because 1,000 million equals 1 billion, therefore 5,000. All right, the next one we have is x. Oh, sorry, and that should actually be is greater than or less than or equal to 5 billion. X plus y less than or equal to 30, because they cannot make more than 30 airplanes. And then the last one is the most complicated one. There must be at least 5 more Type airplanes than double the number of Type B. So Type B airplanes, 5 more, and there must be more than that for the Type A's. So here we are, we have 5 constraints. What is our target objective? Our target objective is they can't build more, they can't exceed 5 billion. So they want to minimize costs. They want to minimize production time. That's their goal. Okay? It takes 3 weeks to build a type A airplane and 5 weeks for a type B airplane. So that's the only part of this whole question that doesn't have an inequality. So that is logically going to be my optimizing function. So here's my rule. Z, because it's optimization, is equal to, it takes 3 weeks to build a type A and 5 weeks to build a type B. And this is production time in weeks. That's my in weeks. That is my optimizing function because it's the one sentence in the whole entire paragraph that doesn't have an inequality, and it has to do with what optimal conditions for my situation. All right, we're going to do one last question.